Hello. So what we're going to do today is we are going to talk about our second day of probability. So let's have you pause the video and let's have you get this problem written down. So some of these today's problems that we're going to look at, it's a lot of the wording that can be confusing. And once you work through the wording, these problems aren't bad, but I can definitely see why probability can be tricky. Interpreting the problem is the hard part here. So when we look at this problem, the probability that it'll rain is 0.18, the probability it is delayed is 0.12, and the probability it rains and delays, oh, I'm sorry, this should be it is delayed, is 0.12. What is the probability that the flight is delayed when it rains? So in my mind, I immediately jump to the 0.08. But that's that they are both happening. So we want to know the probability that the flight is delayed when it is raining. So we know something here. We know that it is raining. So it's kind of like saying that we're given it's raining. So of those rain days, when is it delayed? So there's two different ways that you can look at this. So we're going to look at both. So method one would be to create one of those two-way tables. So we looked at these the other day. So we could say delay, no delay. And then we could divide it this way into rain, no rain. So if we start plugging numbers in here, we see this first one that it will rain is 0.18. So we know that this total here is 0.18. And we know the probability of the delayed is 0.12. So down here is 0.12. And then we can say, okay, well, we know the probability it rains and delays is 0.08. So 0.08 goes right here. And so now we can start totaling some of this. Well, if that's 0.8, this has to be 0.10. And if this is 0.12, this is 0.04. And then we got to figure out these totals. Well, remember, our total should be 1 or 100%. So here we go. 0.18 plus what gives us 1? Well, that would be 0.82. So there's an 82% chance of no rain. So in this first column, our total delayed is 0.12 or 12%. So this column has to be 0.88, which would make this one 0.78. So now when we take a look at it, the flight is delayed when it rains. So we know it's raining. So we know that it's 0.18. And so let's see, we want to know that it's delayed when it's raining. So our total we're looking at is the rain, 0.18. The delayed would be 0.8. And then we could do a couple things. This is a fraction, would be 8 over 18. Or we can jump to Desmos here. I can't remember on Delta Math which way you have to type these in. So 8 divided by 18, 0.44. So our answer would be 0.44 here. Another method that you could look at this is you could look at it as a Venn diagram. So we have rain and delay. And we know it's rain and delayed. We know that that's 0.02. We know our total rain is 0.18. So we know that this would have to be 0.10. We know our total delay. We know that circle is 0.12. So this is 0.04. And so we could say outside this that nothing happens. So that's 18, 19, 20, 21, 22. So would be 0.78. Because again, the total is 100. And we know again, we're looking at what is the probability that it is delayed when it rains. So we're just looking at the when circle. So our rain is the 0.18 and the 0.08 above it. Okay, so let's take a look at another one similar to this and see how this one will go. Okay, so let's say the probability that the Yankees win is 0.57. That the probability that the Yankees score greater than 5 runs is 0.6. And the probability that they lose and score less than 5 is 0.31. And so let's say we want to find the probability that they win given they score greater than 5 runs. So again, this is a nice one where I think it's easier. We are told our total isn't all the games that they gave. Everything that we're looking at is that they score greater than 5. So let's try making one of these two-way tables again. So we could have win and they lose. And then we can have greater than 5 runs and less than 5 runs. And so what one in the table? We know that they win is 0.57. So this first column is 0.57, which would make our lose column 0.43 because it has to add to 1. So our total is 1. We know that greater than 5 runs is 0.6, which means less than 5 runs, 0.4. So we have our total for our rows and our columns, and now what can we fill in? Well, we know they lose and score less. So lose and score less is 0.31, so we know our 0.31 is here. And now it's just like a puzzle. Well, what has to go on top would be 0.12. So over here, let's see, 6 minus 0.12, 0.48 to make that work. And then right here to add to 0.57, 0.09. So find the probability that they win given that they score greater than 5. So we're given this. So we know our total is 0.6. And given that they win, find the probability that they win there. So that would be 0.48. So again, if we move the decimal over twice, we'd have 48 out of 60, and then we could convert that into a decimal. All right, so let's take a look at one last type of probability, and this one is called compound probability. And you guys have done this before, so I bet this type will be pretty easy for you. So in compound probability, we're doing multiple things in a row. So let's say you have a bag of marbles. Contains 5 red marbles, 7 blue, and 4 green marbles. So let's say you need to find the probability you pick 2 green marbles. So again, this is kind of going back to our basic probability. What is our total marbles? 12, 13, 14, 15, 16. So on our first draw, there's 16 marbles, and how many are green is 4. Times our second draw, there's no longer 16 marbles, there's only 15. We assume we drew a green before, so there were 4, so now there's 3. And then you just multiply these together. And again, you can turn it into a decimal, or you can leave it as a fraction. So we have 12 over 16 times 15, 240. Divide that out, 12 divided by 240 is 0.05. And so again, just double check, is it asking for a fraction or a decimal when you type these in. Now, how would this change if I said find the probability? You pick 2 greens, but I said with replacement. So that means if you see a with replacement, it means you're taking it out of the bag and putting it back in. So it still starts with 4 out of 16, but if you put it back in, you still have 16 marbles, and there would still be 4 greens. So 4 times 4 is 16. 16 times 16 is 256. And 16 divided by 256 is 0.0625. So it's just one thing to note in the problem. If it says replacement, that total number is going to stay the same. But if it doesn't, that total number will be going down.